So hi guys, so today we would be starting with another research paper. This is going to be a deep learning research paper, and the title, as you can see, it's a deep neural networks for YouTube recommendations. So yeah, we would be looking at YouTube recommendation system, how it uses deep learning and machine learning in the processes, and we all use YouTube at least once every day. So we should be aware of how machine learning and artificial intelligence are playing a very crucial role in this system. So this video is going to be coming in this. The whole machine learning research paper is going to be getting covered in around 2 to 3 parts. So this is just the first part. So, as you must be knowing that YouTube is the world's largest platform for creating, sharing and discovering video content. The recommendation systems are responsible for helping more than a billion users. So for a fact, YouTube is the second most visited website on internet every day. So number one is Google, obviously. So you every minute billions of videos are uploaded to YouTube, and yeah, a lot of things keep happening every minute on YouTube. People give a view to a video, like, share, subscribe, and commenting. All the things keep happening. So yeah, machine learning plays a very big role in this whole recommendation system. So if you don't know about what is a recommendation system, I would just show you. Suppose I this is my YouTube, and as I open it, you can see a lot of videos are available here, which shows that what is my interest. As my interest is in Flutter, my interest is in that you can say cricket. So this is how all these things get recommended. So this all recommendation is part of the recommendation system. The YouTube system recommends you which video you want to watch. So you must be thinking sometimes that okay, I watched a video regarding any sport, particularly like football or cricket, and after that, if you open YouTube again, you would see that there are some videos in the recommendation area that are related to that particular sport, that is cricket and football. So this is a very big thing that you must be thinking, that how YouTube gets to know that which video I want to see, or which video I would like to watch whenever I open YouTube. So this is the recommendation system, and recommendation system does not only work on YouTube. Recommendation systems are among the most common forms of machine learning that users will encounter, whether they are aware of it or not. Big companies like tech companies like Facebook and Twitter, and suggested below videos on YouTube, are all using recommendation system to make their users feel more comfortable on their platforms. So coming to the part, you can see here that Google YouTube has undergone a fundamental paradigmic shift towards using deep learning as a general purpose solution for nearly all learning problems. The system is built on Google Brain, which was recently opened source as TensorFlow. So this research paper is basically from the time when TensorFlow was just introduced to the community of developers and machine learning enthusiasts. So that is the reason here it is written that our system is built on Google, which was recently open sourced as TensorFlow. For now, it's around 4 to 5 years that TensorFlow has been so stable, and it provides a flexible framework for experimenting with various deep neural network architectures using large-scale distributing training. The models learn approximately 1 billion parameters and are trained on hundreds and billions of examples. So you must, whenever we talk about machine learning, training and all, one thing which I particularly focus on, you must have seen in my video, are data. Data sets are something that should be very, very clean and accurate towards the thing you want to train your model for. And for that, YouTube has got a very big advantage, because the consumer is already producing the data for you. Suppose we are the consumers, we are their customers who they want to give the best experience, and we are already providing so much data for their machine learning algorithm to learn from. Just imagine, around billions and billions of data is available on YouTube regarding videos of any particular kind. YouTube can easily train its model using that wide data set. Yeah, it may be using some filters to figure out the best data, but definitely it has got no limit or any limitations or any restrictions regarding the data part. So let's come to back to the topic, that how all this is working. So yeah, as you can see in the figure, we would start with the background, some background if you need to have. There are basically two main factors behind the YouTube's deep learning approach towards the recommendation system. I would just show you this. The first thing is the scale. I would use a pen to denote that. So there are two things that matter the most. The first one is scale. I would denote that through S, and then another one is consistency, that I would remove through yeah, C. So what is scale? Basically, due to the immense sparsity of these matrices, it's difficult for previous matrix factorization approaches to scale among the entire feature space. Hence, additionally, previous matrix factorization approaches have a difficult time handling a combination of categorical and continuous websites and variables. And what is consistency? Many other product teams at Google, which means have switched to deep learning as a general framework for learning problems through TensorFlow, have experienced that it is really easy to train and test and deploy deep neural networks in a distributive fashion. So if you come to the PDF also, the same thing has been written, that all this is possible because of TensorFlow and how the deep neural networks are making things really easy for YouTube and Google to make recommendation system more accurate and easy to train and deploy. So there are basically three main reasons why YouTube uses deep learning. The first one is it's really easy. The second thing is that technology used, that is TensorFlow, has been was the first technology as a deep neural network technology to be implemented directly on production part. So if you see here, would see the system is comprised of two neural networks, that is candidate generation and one for ranking. So so if I would just explain all the things with this figure now. Yeah, you can see before telling you that what this figure is doing, I would just tell you what this all terms have been written. You must be thinking, what is candidate generation? So the candidate generation networks take the user's activity history, that is example of the, you can take the example such as the IDs of videos being watched, the search history, and the user level demographics. Means suppose I am sitting in India and seeing a video of Indian team winning a match over Australia. Now my recommendation system would only recommend me the videos that are related to Indian team, because I am again seeing videos related to Indian team and all the things that are related to my region. So it would also recommend me the video that are related to my religion and demography. The general idea is that the network should optimize for precision. Each instance should be highly relevant, and even if it is requiring foregoing some items which may be widely popular but irrelevant. So YouTube has a simple algorithm that it should give the users the best quality. Now suppose I would just, yeah, this is a stack and this is another stack. In this stack there are suppose I searched a video X, and now in this stack there are some popular videos that don't match exactly X, yeah, but they are related something to X. Now this stack has something that is totally relevant to X, but it is not popular. Hence, YouTube would go for the second one. It wants the user to get the most relevant recommendation, not the most popular one. So for this, the candidate generation comes into play, where where it outputs hundreds of videos that might be broadly be applicable to the user. So now we will talk about only like here till candidate generation. What happens? This is the video corpus. You can imagine this as a very big bucket where trillions of videos have been put up in the YouTube, and YouTube sees every video. The algorithm sees every video, every title of the video, what their description is basically telling about the video, and through that it basically filters the video to hundreds. Means suppose there were I am Vishesh and I am using YouTube. Now I want to search something. I really see something related to TensorFlow. Hence, what would happen? Whenever I would open YouTube, YouTube would take 3 million videos, and suppose there are only 3 million videos on YouTube, and then it would do candidate generation, that okay, what Vishesh search history is, what the demography is, and what basically the videos that are being watched by me consider to. Hence, from that it would give me 100 of videos, and from this 100 of videos another filter would be done. Now that is ranking. Now you must be thinking, okay, candidate generation is giving you 100 of videos, then why ranking has to be done? So the ranking network takes a richer set of features for each video and scoring each item from the candidate generation network. For this network, it's important to have a high recall. It's okay for some recommendation to be not very relevant as long as you are not missing the most relevant items. So you can imagine like this. I would just take another, yeah. This is the recommendation system, and this is a very big okay, I would just draw another one. Yeah, this is a very big filter. The videos are falling in this filter, and after that only few videos get to it. Now after this is another system which is more denser than this. It's really very dense, and after this only some videos get passed according to the rich features, like what video is basically being published, the date, the timings, and the keywords are matching or not, and according to that, suppose 3 million videos were here, only 100 videos got here, 100 videos got here, and after that only 36 videos, that is 3 dozen videos, only got here. Now what about these 36 videos? Whenever I open YouTube, here is my YouTube, and this is the search panel. These 36 video would get in a particular ranking, that okay, this video would be recommended first, this would be recommended second, this as third, this as fourth, and this is how the ranking system works. So you can see here the candidate generation during the enormous YouTube corpus is windowed down to 100 of videos that may be relevant to the users. Now uh, after that, the recommendation as a classifier, if you want to see how this mathematics behind work, you can see this, that the multi classification has been done here, as you must, there are a lot of classes. Just imagine there are millions of classes in on YouTube. There's not only a single type of video or any single particular music, gaming, or there are trillions of videos that are uploaded every second. So you can imagine how many classes must be there in YouTube. There are multi-classes video in this algorithm. Although explicit future feedback mechanism exists on YouTube, we can use the implement feedback of watches to train the model, where a user completing a video is a positive response. So you can imagine like this. Whenever, suppose I have my YouTube channel, on that I upload video every day, and every day YouTube sees that okay, this video has been seen by 300 people, but only 150 people watched it full. Hence only 150 people found it useful, hence it would be ranked according to that. But if someone uploads video other than me on TensorFlow, and he or she gets 600 views, and out of that 590 people watched the whole video, hence YouTube would be recommending that to the other people, because according to YouTube that person's video are more positive because people are seeing it full. Hence this is how all these things and features are working. This choice is based on the orders of magnitude more implement user history available, allowing us to produce recommendations deep in the tail where explicit features is extremely sparse. Now coming to the efficient extreme multiclass, this is basically like that. You can imagine to efficient train such a model with millions of classes I just told you about. For each example, the cross entropy loss is minimized for the true level. If you don't know about cross entropy, you can go to my previous research learning paper. I have told in detail about cross entropy, how it helps in handling the curves of dimensionality and all, and the overfitting part. So at several serving time, we need to compute the most likely n classes video in order to keep the top n2 present to the user. So as I told you, only in this video part, only suppose this for the m, then only according to me only one m by 600 times 600 videos get to the user. Means this is just a number I am telling for example. but it can be any number depending on what you are searching. So you can see uh, previous system at YouTube relied on hashing, and the classification described here as a similar approach. If you don't know about hashing, basically it's a data structure. It works something like this. I'm not sure if YouTube used it like this, but you basically put the videos, put something inside hashing. This is the key, this is the value, and after that you keep putting videos like this. This is the key, this is the value, this is the key, this is the value, and whenever user searches something, you will match the key with that. If it is available, value is given to the user. I'm just telling you what hashing is, basically how YouTube used this according to the systems. I am not sure of. So that is the reason we are learning the deep neural network, because that is making YouTube do the work quite flexible and easily. Coming to the model architecture, before the model architecture of the whole process works like that. The generation network that poses the candidate generation problem as an extreme multi-classification problem, where the prediction problem becomes the accurately classifying class. So you can think like something like this, that the model architecture is following a traditional tower approach. It is following a proper tower approach, that this is a tower, and where the bottom of the network is the widest layer. Okay, I just do something. You can imagine like this, that this is the tower, yeah, and this is the bottom layer, and this is the widest, the bottom layer is the widest one, and each layer after that half the width of the network. So this was the most widest layer. Now this is getting half, this is getting half, this is getting half, and this is how the whole system, whole model architecture works like. If you read this in detail, you would find that the authors experiment with different networks varying from one layer to four layer deep. The smallest layer is one of the 256 ReLU units. If you don't know about ReLU units, you can go to TensorFlow video. I will have explained in detail. And the smallest layer is 256 ReLU units, while the widest layer is 2048 ReLU units. You can imagine how big the layer is, and is 4 layer deep. So if yeah, here you can see what it basically does is, it is using, the model is trained using negative sampling, where we attempt to reinforcement negative results by only propagating a subset of 3 negative examples rather than all. So what we are doing, we are only taking a subset of 3 negative examples in one, instead of taking all. At serving time, an approximately nearest neighbors algorithm is used. So the nearest neighbor algorithm is being used here. It's a very famous algorithm. So one example that I would like to show here is the example age feature, that how all these features, the heterogeneous feature signals are being used. So many hours worth of videos are uploaded each second to YouTube. Recommending this recently uploaded fresh content is extremely important for YouTube as a product. So every time you would open YouTube, you won't want the YouTube to show you videos that are 6 to 5 years old on that topic only. Suppose I'm searching about cricket. I won't like if YouTube would agree every time I open it is showing me videos of cricket that are 5 to 6 years old. I would like the YouTube to show me videos of cricket which are only 1 month old, or a recent week, something like that. So we constantly observe the users prefer fresh content through, not at the expense of relevance. In addition to the first order effect of simply recommending new videos that users want to watch. Others are trying to say the same thing. So the machine learning system often exhibit an implicit bias towards the past, because they are trained to predict the future behavior from historic examples. The distribution of video popularity is highly non-stationary, while the multi-dimensional distribution over the corpus produced by the R recommender would reflect the average watch likelihood in the training window of several weeks. So yeah, if you see here, this is the baseline of the model, the blue line, and the red line is with example age, and green line is the empirical distribution. You can see the class probability and the days since upload. The part at which the example age and the implicit value and the baseline model are colliding. At that time the distribution value is at its peak, and same with the class example age and the baseline model. Hence, you can see here this line is really crucial. To correct this, we feed the age of the training example as a feature during training. At serving time, this feature is set to 0. Means when you are feeding the age of the training example at the time of training, but when you are serving that serving, the feature is set to 0 or slightly negative, to reflect the model is making predictions at the very end of the training window. So this is how this whole part is working. I would explain the next thing in the next videos, because I don't want the video to get too long and boring. So I would just revisit all the things that I have told you. This is the user, this is the main model that is working on. The video corpus, millions of videos are filtered into candidates through candidate generations 200, and after that through ranking to dozens. And after that, SIBO VY, we will talk about this in the next video. Basically, what is SIBO VY? It is been explained, so because of candidate sampling. So if you want to read about candidate sampling in detail in TensorFlow, you can go to this video, this article I mean, and you can read in detail. Else in the next video, some things I would like to clear out is part of candidate sampling and how the label and context sections are playing role in this whole process. So this was it for the video. The next 3 to 4 pages I would try to explain it, cover in the next video itself. Yeah, 4 pages are there after this. I would try to cover all the 4 pages in the next video. So thank you for watching the video. Thank you and have a nice day.